theorem using Pspice tool. So I'll be handling two different problems in this particular video, where one of the problem will have a normal independent sources, and I will be explaining you how to handle dependent sources in superposition theorem, and then we'll see how to simulate that using Pspice tool. Okay, now let us see how to simulate the superposition theorem using Pspice tool. Okay, so here in this problem, they have asked to find out the voltage across 20 ohms Vx. So we need to find out what is Vx using superposition theorem. So first of all, we all know what is superposition theorem. In superposition theorem, what we do is we try. See, there are four different sources here, where we have two voltage source and two current source. In superposition theorem, every time we keep one source to be active, and we remove all other sources accordingly. Like we open the current sources and create an open circuit, and we try to replace the voltage source by a short circuit. Okay, so if we do that by keeping individual any single source at a time which is active, then we do get four different circuits for this particular circuit, because we have four sources. So whenever you find out a voltage across 20 ohms by keeping any one source to be active, you try to note down the voltage across that 20 ohms. So here in these diagrams you can see I have written four circuits here. So this is the first circuit where only 16 volts will be active. Other sources are removed and replaced accordingly. So here 3 amps is removed. So an open circuit created across this. So it is as good as no component across that particular terminal. And this voltage source has been shortened. So this is a short circuit terminal, what you can see. And this current is also removed, and open circuit is created across that. So this is the first circuit what we get, where we find out V1. Similarly, we will keep 3 amps to be active, and we remove all other voltage and current sources. So this gets shortened because it is a voltage source, and here also it gets shortened because it is a voltage source, whereas current source is been removed. Similarly, there what we find out, V2 will be found. So then we will find out V3 across 20 ohms by keeping 10 volts to be active and removing all other sources. So here I have created short circuit because it's a voltage source, and I have removed 3 amps and 1.5 amps because it is a current source. Then finally, circuit 4 is been found by keeping a current source here. So a current source is been kept 1.5 amps, and other sources have been replaced. So here voltage source is been short, here voltage source is been short, whereas here the current source is been removed. Now we got four different voltage values. So the superposition theorem says the total voltage Vx is equal to summation of all these four voltages that are been found by keeping any one source to be active. So what we need to do in Pspice now is we need to construct this main circuit, and we need to note down what is Vx. Okay, in superposition theorem, by using Pspice tool, what we do is we try to construct this whole circuit, and we'll try to take the voltage value in this circuit. Then what we do, we will construct these four circuits individually and note down these voltage values V1, V2, V3, V4. Then manually we'll add these four voltages, and we'll try to verify whether the addition of these four voltages are equal to the Vx that we have obtained in this circuit. Okay, so that is what we are going to do now. So let us do this simulation in Pspice. So first I'll construct this main circuit where Vx is being found. So we have only two resistances, so I'll place that two resistances here. So I have one resistance here which is of 20 ohms, the other resistance is here which is of 80 ohms. So I'll just zoom it. So I'll give the value later. First we'll place all the other components. So we do have VDC, DC voltage. One is here, the other one would be here. Then finally we do have two current sources, IDC. So one current source with in this direction here, and the other current sources in this direction here. Okay, so this is the circuit what we are implementing. So I hope it it is visible to you. Okay. So I'll just place it. So this is the circuit which we are implementing. Now what I do, I'll put the wiring. So this is connected here. Okay. Now this is connected to voltage source. This is connected here, and this is connected here. This one, and then this one, and finally this one. So this circuit is similar to this circuit, whatever we have. So now my job is to place the ground. So ground should be placed. Okay, so that is fine. I'll give the values for all this. So this is 16 volts, 16V. Then we have 20 ohms. So this is 20, and then this is 80, and then this current source is 3 amps. This voltage source is of 10 volts, so 10V. So this should be 3 amps, so I should give 3A. And finally this one is 1.5 amps, 1.5 amps. So I got all the values now. My job is to save. So I'll just save it as super 1. So this is superposition theorem. So I'll just save it as super 1. Save it. So now the circuit is been saved. My job is to execute this. So just simulate it. No error. See, it's all showing current. So we need voltage Vx, right? So I'll just press on voltage. So now I got the total voltage, whatever I have, should be found through this across this particular what do you say, 20 ohm resistance. So for that, I place the voltage source here, save it, simulate it. So I got voltage at this point is 62 voltages, 62, whereas the voltage across this R1. So here the voltage across R1 can be found by taking the subtraction between the 16 volts and 62.80. So the voltage across R1 is what? So here, if I go back to the circuit, if I go back to the circuit, this voltage whatever I got is 16 volts, and this voltage whatever I got is in Pspice tool, it is 62.80. 62.80 I got. So now what I'll do, I'll take plus 16 minus 62.8. Therefore 16 minus 62.80 would be equal to Vx. So therefore finally you'll see Vx, what we get is minus 46.8. If you subtract this two, I get minus 46.8 volts. This is the value of Vx that we need to find out. If I execute individually these 4 circuits and add up all these individual voltages. So therefore I'll execute the first circuit by keeping 16 volts into consideration. I'll just replace here only, so I'll not go to drawing a new circuit. I'll just remove this resistance, current source. I'll remove this. I'll remove this. I don't need this. So what I'll do, I'll just draw the wire which connects this to short circuiting the voltage source. That's it. So I don't need current source. The current source will behave as open. Now this is the circuit which we are going to save it now. Now you try to execute this and see what is the voltage value that we get here. So this is 16 and this is 12.80. So what I do is I'll try to go with 16 minus 2.0, 12.80. So here what we got is this is 16 and this voltage whatever we got is 12.80. That is what I feel. Yeah, 12.80. Now I'll take out the calculator. I'll just subtract 16 and 12.80. 16 minus 12.8 is 3.2 volts. Therefore, I got V1 to be equal to 3.2 volts. I got V1 to be equal to 3.12 volts. Okay, now I'll try to construct this circuit. So I'll go back. I'll remove this and I'll short. And then I'll replace with. So you need to take the printout or screenshot of the individual circuit. I am just doing it in the same circuit, but your job is to take the screenshot of individual circuits. Whatever the values that you get individually. I am just showing in this video how to do the construction, but while you taking the screenshot of every circuit, you should do it so that you can put a record of what you people are doing in this experiment. So now I'll keep only the current source which is active and all other sources are either short or open if it is voltage and current source respectively. So this current source value is 3 amps. So I'll just say 3 amps and I'll just say OK. Now this is the circuit which we have built with the same components of resistors whatever we have. So we'll save it and then simulate it. Now if you go back and see the voltage values, I got 0 volt this side and 48.00 volts here. Therefore, if I go back to the written circuit, so I got 0 voltages here, whereas here 48 volts. So it means that plus 0 minus 48, therefore V2 which I have got is minus 48 volts. Minus 48 volts. Now I will construct circuit 3. So circuit 3 is again remove this. So in circuit 3 I need a voltage source 10 volts between 20 ohm and 80 ohm. Therefore, I'll just remove this wire. I'll place a voltage source of 10 volts here. So I'll draw a wire now. So this is 10 volts now. And press OK. So that's it. This is the circuit. Now you need to find out what is voltage across this R1. So save it, simulate it. So once we simulate, we will be able to see what is voltage. This is 0 volts and this is at this point it is 2 volts. So therefore, if you try to write this, I got this to be 0 volts and this to be 2 volts. So therefore, V3 equals 0 minus 2. So it is minus 2 volts. V3 equals minus 2 volts. Now finally, I need to find out what is V4. So now what I'll do, I'll remove this. I'll create a short circuit here. And now I'll place a current source in this direction here. And then I'll short this nodes. Okay. Now this current source value is 1.5 amps. And then I'll press OK. Now this is the circuit. Save it. Execute it. So finally, you will see the voltage is 0 volts in the entire circuit. The reason is this current source is now creates an infinite loop where this 1.5 ohms flows in this particular loop infinitely, where no current flows through these resistances. Due to that, there will not be any voltage drop across these resistances. Therefore, the voltage drop across those resistances will be zero. Finally, the answer for V4, so the value for V4 is equal to 0 volts. So we got all the values of V1, V2, V3, V4. So you are going to add those values. So V1 was 3.2, V2 was minus 48, V3 was minus 2, and V4 was 0. Therefore, it is 3.2, 3.2 is already there here, so minus 48 minus 2, which is equal to minus 46.8, minus 46.8 volts. So this Vx, whatever we got by constructing these individual circuits, is equal to this Vx, whatever we got in the main circuit. Therefore, this proves the superposition theorem. Let's do this problem where I do have a dependent source here. So I'll be explaining you in this problem how to connect the dependent sources in the circuit. Okay. So here also we have superposition theorem that we need to use to find out the current I. Okay, to find out the current I using superposition theorem. So when you have a dependent source, you cannot do anything on the dependent source. You cannot remove that source. So it is as good as not considering dependent sources with the superposition theorem to either short or open. So dependent sources should be kept as it is in the circuit. Only superposition theorem will be applied to remove the sources only for the independent sources. So here we have both independent voltage sources. So we do get two different diagrams where we find out current through 8 ohms. So that is what we need to find out I, which is current through 8 ohms using superposition theorem. So when I keep 20 volt source here and I will remove 12 volt source and create a short here, I'll find out the current through 8 ohms, which is I1. See here, I have kept the dependent source as it is. So now I'll keep this 12 volt source and I'll replace that 20 volts in short and find out current I2 through 8 ohms. Okay, so this current I1 and I2, whatever I found, I will try to add that two to find out the total current I. So this current, after adding current I1 and I2, is equal to I, whatever we get. So that I should be equal to this I in the main circuit, whatever I find out by using Pspice tool. Then the superposition theorem will be proved. So let us now we construct this first main circuit and find out what is I. And then we'll construct these two circuits to find out what is I1 and I2. Then we'll see whether the total current of I1 plus I2 will be equal to the current I, which has been found in the main circuit that we have implemented. Okay, we'll go to the Pspice and we'll construct this circuit now. So here in this circuit we have 4 resistances. So I'll place the resistance first. So I have one resistance here, another resistance is here. Then I have another resistance, then I have another resistance here. So Control R will rotate the components. So just zoom it. So this is the resistances that I have. I have two independent voltage sources, so that is nothing but VDC voltage sources. So I have one voltage source here. So I have minus and plus in this way. So this is minus and this is plus, whatever I have. This is minus and this is plus. That is how the circuit is here, minus and plus. In that way you should place the component. Now I need to place a dependent source. Now first you should see what type of dependent source it is. So you have plus and minus, therefore this is a voltage source and it is dependent on voltage. Therefore I can say this is voltage dependent voltage source. Voltage dependent voltage source. So for placing the dependent voltage sources, we do have an alphabet E. When I search for E, it says voltage controlled voltage source. Search for F, you have current controlled current source. Search for G, you have voltage controlled current source. You can see on the description whatever I am saying. Then if I try H, it gives you current controlled voltage source. So I need voltage controlled voltage source, so I'll type E. So when I type E, you see voltage controlled voltage source. So I'll place that at this particular point. Okay. Now this is the circuit. Now our job is to do the wiring. So I'll do the wiring here. So this is connected here. This is connected here. So all are connected to ground. Then this is connected here. This is connected here. This is connected to this particular. Now my voltage is dependent on a voltage. So if you go back to the circuit, what voltage it is dependent on? It is dependent on Vx. So where is this Vx? Vx is nothing but voltage across 18 ohms. So plus is connected at this point, minus is connected at this point. So this voltage Vx is nothing but voltage across 18 ohms. So what we need to do, this plus and minus should be connected across this resistance. So therefore this plus will be connected to, I'll take from top because it should not short anywhere else, here, whereas this minus will be connected to here. So therefore voltage dependent is across this resistance. Now this plus and minus is nothing but this plus is connected to 8 ohms, this minus is connected to ground. Therefore this plus is connected to 8 ohms and minus is connected to ground. Therefore I'll take this 8 ohm resistance, whatever we can see, connected to plus, and this is connected to ground. Now the dependent source is being placed accordingly, right? So we'll now give the values here. So this voltage source value is 12 volts. Okay, now this is 18 ohms. This resistance is again 18 ohms. This voltage value is 20 volts. This resistance is 3 ohms and this resistance is 8 ohms. And now this dependent voltage value, if you will see, it is 0.2 times Vx. So this 0.2 will be the dependent source gain. So if I double click on this dependent source, it will ask me the part is E. So gain, if you see here, this is 1, it says by default. We will change that to 0.2. We will change that to 0.2. Then I will save attribute. Okay. Now the gain of this particular voltage source is now 0.2, which is 0.2 times Vx what we have. So that becomes a gain. So I hope now you realize how to handle the dependent source. Now the circuit values and all other things are been given here. The last component which we need to connect here is ground. So let me connect that. So ground is connected now. So my job is to save it. I'll give some name. So I'll just give super 11 because even this is a superposition theorem. Any name you can give. So save it. So now this schematic is saved. My job is to simulate and find out the current at 8 ohms, current through 8 ohm resistance. So now save it and simulate it. So no error. So therefore when you go to the simulator and press on current I, so I'll get 130.84 amps is what the current that we get through the 8 ohm resistor. 130.84 milliamps is the current that we are getting through the 8 ohm resistor. Okay, now let me note down this current value 130.84 milliamps. So current I is equal to 130.84 milliamps. Milli means 10 power minus 3. So it is as good as 130.84 into 10 power minus 3 amps. Okay, now we got this current. Now let us see what is I1 and I2 by having any one source. So now I'll just change it in the same circuit. So I'll remove this voltage source. I'll short it. That's it. So this is fine. So save it. Now we'll see only this voltage source is acting and this is being short. We are not touching dependent source. So therefore now when I execute this, I will be getting current through 8 ohm is this one. So 186.92 milliamps. 186.92 milliamps. So I got I1 to be equal to 186.92 milliamps. Now I'll remove this voltage source and create short and I'll replace 12 volts there. So I'll remove this voltage source and create a short here, and then I'll replace this voltage source with 12 volts. So I got it. So this is the circuit which we have now. Now we'll save it and then again simulate this. So when we simulate, we'll see what value that we have got voltage here. We have got, sorry, I need to find out current here. So I have got 56.08 milliamps. See, the current is flowing in a reverse direction. The current is flowing towards this direction. So I will take this as minus 56.08 milliamps. Because see the arrow mark, it is flowing in a reverse direction. I need to take in this way. So therefore it becomes minus 56.08. So I2 equals minus 56.08 amps. Now I will add these two values, 186.92 milliamps minus 56.08, sorry, I think even this is milliamps. Yeah, 56.08 milliamps. So this is milliamps. So if I try to use the calculator and find out what do I get, let me see. So it is 186.92 minus 56.08. I got 130.84. So I get 130.84 milliamps. If you see, this answer is equal to this answer. So therefore the superposition theorem is verified. So this problem will explain you how the dependent sources are connected in the circuit. So I hope you are clear with this problem, and I hope superposition theorem realization using Pspice tool is fine for you.